Welcome to our introduction to agriculture in Egypt. In the first episode, we looked at the history of agriculture from the ancient times until today. And in this episode, we're going to look at the challenges of agriculture on the present day. So the situation that we're having right now is pretty much a country fighting desertification. But we will illustrate this in the coming. At the beginning, let's look into the agriculture in the Egyptian economy and the role it is taking. As you know, 96% of the country are actually desert, not fit for agricultural use, and only around 4% can be used, like as arable land, can be used for agriculture. At the same time, agriculture is taking 80% of the national water resources, so thus leaving only 20% for human consumption. So this is something, a very, very high number to which we will come back later as well. Nevertheless, agriculture is one of the most important sectors within the economy, for it contributes 14.5% to the gross domestic product and employs 50% of the labor force in its direct or indirect activities. Direct activities, of course, like farmers working in the fields, and indirectly, like, for example, truck drivers, people engaged in transportation in the markets and food processing. Another remarkable fact is that 95% of the production is consumed domestically. Why this is the case, we will see in the coming. So what are the major threats? We can identify 3 points that are threatening agriculture in Egypt today. The first one is poverty, second one, food insecurity, and climate change. So let's talk about poverty in the beginning. Poverty is a result that we have a lot of small and fragmented land holding. 50% of the landowners work on only half a hectare of land, and thus there's a high imbalance between like high value and strategic crops. So however, 80% are not fit for exports, although the farmers could do much better. So this is why they're not fit for export, because they're using old technologies, inefficient irrigation methodologies, and so they are not fulfilling the quality that would be needed for like international markets and for exports. So this is one of the reasons why in fact 95% stay within the country and are consumed there. The fact of land distribution is also illustrated on this curve. What we see here is a classic Lorenz curve, as you might know it, and what it shows is, first of all, the landowners and the area owned by the landowners. So the line in the middle here shows the ideal distribution, which means a situation in which there's like equal land distribution, and for example 50% of the people earn 50% of the land, so a very just distribution of land. However, this is an ideal scenario that is almost never the case in reality. For example, before Nasser's socialist land reforms in 1952, we see the dashed curve at the bottom. So there we had a situation where 20% of the area, or 20% of the total area, was owned by 90% of the people. So this actually implies that the remaining 10% of the people owned 80% of the lands. So this reflects the situation that there were a lot of like large farms that are producing like on a large scale, while we had a big majority of small scale farmers that were operating on just 20% of the total area available for agriculture. This situation improved after Nasser's land reforms. This is a dotted line, which is the second from the top. And here you can see that 20% of the area was owned by 40% of the people. So we see that there's improvement in the land distribution. So like more landowners own less of the total acreage. So it implies again that 60% of the people own the remaining 80%, coming closer to the ideal curve of equal distribution of land. Unfortunately, today we had a drawback. The situation got worse again, and in 1995 we're back to a situation where 70% of the landowners own 20% of the total area. It is also a very, food security is threatened by a very sensitive base of natural resources. There is 3.5 million hectares of arable land, translating to 3.5% of the total area of the country, that has to feed 82 million people. I think this is even an old number, so by now the latest number that I heard was 85 million people. So per capita, only 0.04 hectares are available as agricultural production area for people. Furthermore, due to the high use of fertilizers, increasing salinity of the soil takes place, and the soil fertility is actually decreasing. We are losing soils through salinization, through construction in the fertile land, and also through wash-offs and run-offs of nutrients to the water resources, to the Nile. At the same time, we're facing a situation where the water resources are very limited. Egypt pretty much depends on the Nile. As Herodotus told us in the 5th century, Egypt is a gift of the Nile. So without this water coming from the Nile, so there's no agriculture possible in the country. As said, the fertilizers play a very big role in agriculture and also to food security. After the construction of the Aswan High Dam, which was finished in 1971, we had a situation that the annual Nile flood curtailed, and no more silt and fertile organic matter was washed on the fields. This was natural fertilizer of the ancient days. But this ceased to exist. So what happened was that the country replaced this natural fertilization by introducing not less than 128 different types of fertilizers to the market. So today, Egypt is one of the countries with the highest fertilizer application per hectare, in the world. So this caused a lot of, or entailed a lot of problems. Through the heavy use of fertilizers, the natural resource base, the natural soil organic matter decreased more and more, so the nutrient base is depleting, which means that year after year, more fertilizers, more inputs have to be given to the land in order to keep yield stable. So this is a point that makes agriculture also very vulnerable. This is illustrated in the chart that we're going to see here. The chart compares fertilizer use in the old and the new lands and shows us how many tons are applied. And the different colors represent the years. So we see, let's take, for example, nitrogen. We see in 2002, in the old lands, the fertilizer use was already pretty high. It was about 90 million tons in total. And this is even due to increase until 2017. Why does it have to increase? Again, because the soil, the resource base of the soil is depleting. To keep the yield stable, we need to apply more fertilizer. Here we see what I said before also. Around 500 kilos of fertilizers are used per hectare of arable land in 2011. So we compare this to other countries and see that Egypt is way above. But one thing that we shouldn't forget is one special feature of agriculture in Egypt. Here we have 2 crops per year instead of 1 crop in most of the other countries. So this is why we have to see this number in relative terms. So per season, let's look at it per season, it's still 250 kilograms of fertilizer per hectare, which is still, as you can see, way above global levels. Another factor are the fertilizer prices that makes the sector very vulnerable to global market volatilities. You can see that between 1960 and 2010, within 50 years, the price for nitrogen, for example, is like 9 times as much as 50 years ago. So this also implies a rise in cost. So the cost for production have risen considerably in the last 50 years because we need to apply more and more fertilizer per hectare, and the cost has also risen considerably. What this means, we're going to see in our third part, so I hope you have an incentive to follow us for the third part as well. And another important aspect is also the soil degradation through to salinization. Salinization occurs when high evaporation occurs of the irrigation water and leaving the remaining water with higher salt concentrations. In the past days, this was not so much a problem because also the annual inundation washed away the salt from the fields and thus cleansed the fields. We don't have this anymore today. The water for irrigation stays in the field, it evaporates and thus leaves behind all the salt, which is then polluting the soils. So the salt in the soil is not dangerous or toxic, but it considerably reduces the fertility of the soil and puts a lot of stress on the crops grown there. On the map here, we can see that almost like all areas in Egypt which are used for agriculture are actually facing troubles with salinization. Of course, the biggest part where this happens is in the Nile Delta, but also close to Aswan, and all of the oases are affected by effects of soil degradation due to salinization. Another aspect that puts a lot of pressure on the sector is population growth. In 2009, 0.04 hectares of arable land was available per capita. This is really a decline compared, for example, to the number of 1821, where about 5.2 hectares were available. So all advances in the sector are ultimately also eaten up by the growing population. However, there was a achievement. We can say that the population growth rate in the past years was declining from 2.4 to now to 2%, but still growing population is an issue. So the sector is under stress because a decreasing area of arable land has to feed more and more people. We can see this also in the area here. Egypt's arable land requirement compared with its supply. So we can see here the basic case. We have the land area that is available, which is here in the optimistic case increasing a little bit due to success stories in terms of land reclamation, and in the pessimistic case staying the same, even slightly decreasing as we are losing arable areas due to salinization, due to overutilization, and also due to construction in the arable land. And at the same time, we need more and more land for consumption, which means given the growing population, we need more land to feed the people with a shrinking base of land. As said, a lot of hope is put in new land reclamation projects. In the past 20 years, the government has done a lot of efforts to reclaim land from the desert, to actually green the desert and start agricultural there. So two prominent projects are, for example, Toshka and the Al Salem Canal. But newly reclaimed land is relatively poor in soil organic matter and in nutrients. So in the beginning, it needs a lot of inputs to actually build up the base, the soil organic matter in the soil, to build up the base for successful agriculture. So if you start applying, for example, fertilizer in this poor lands, then a lot of the nutrients are going to be washed off. So you need to build up the soil, to build up the soil organic matter so that the nutrients can be kept in the soils. How this is done, also you can see it in the third part of our introduction. Here we can see land reclamation projects underway. Basically, all along the Nile Valley, land reclamation is going on. A lot is planned, a lot is already under reclamation, and However, the reclaimed land, the success stories in this field are relatively few. So it's something that needs time to get fertile land from the desert, and also a lot of projects fail. So not too much hope should be put on the land reclamation. Another aspect is water availability. As said before, the water resources in Egypt are coming mainly from outside Egypt, from the Nile. 95% are coming from outside with the waters of the Nile, and of this 95%, 80% go into agriculture. So you see that agriculture is a huge leverage for water supply and in Egypt. Recently, there were renegotiations around the Nile water with the other Nile basin countries, and with climate change, with increasing surface temperatures, with increasing need for irrigation within the agriculture in Egypt, there's an increased need for water, and this puts political tensions in the negotiations. And Sadat already said in 1979, the only matter that could take Egypt to war again is water. So it is well worth to look at the water issue and to increase the efficiency of irrigation in agriculture. But here also we see again the water requirements for Egypt's agricultural commodities. The red line presents the renewable water resource available for agriculture in the baseline scenario. In the optimistic case, raising why? Raising to increase water inflows from outside Egypt due to successful negotiations, for example, due to increased rain. And in the pessimistic case, this renewable water resources available stay the same, and there's even a slight decline starting from around 2010. At the same time, the water volume needed for agriculture for the domestic production, which is represented by the green area, is increasing. And what is significantly increasing is the water volume required for exporting crops. A very important aspect is, of course, the Aswan High Dam, which I mentioned before. There's a relatively high irrigation efficiency, but if you just take the dam by itself. However, the field irrigation efficiency is much less, which means that the water applied to the field is not used efficiently. In fact, a lot of it is run off by the fields. And if this occurs, let's say around Aswan, the losses can be reused downstream. However, after this distance and after washing out a lot of nutrients from the fields and from the soils, there's a heavy nutrient pollution actually of the water. And then people use the water of the Nile for pretty much everything. So upstream, the quality of the Nile water has already decreased considerably. Climate change puts also a very high impact on the agriculture in Egypt. It is highly affected, especially in terms of sea level rise. I will just address two points here briefly. The coastal resources are ranked very high in impact. So we can see here that the certainty of impact is medium to high, and the severity is very high. Why? Because the coastland of Egypt is directly bordering to the delta, which is the main growing area within the country. So losing agricultural area there actually loses a lot of the total land available. Increasing temperature thus means, for example, increased surface temperature means, as said before, increased needs for irrigation, but it also means sea level rise. And this is something that is threatening the country a lot. And as we're gonna see here, there's a prominent study by Dasgupta, which was published in 2007, and he constructs scenarios of sea level rise for 1 meter, 2 meters, 3 meters, up to 5 meters, and he comes to the result that Egypt is actually the second most affected country by sea level rise after Bangladesh. Why? Because a lot of the arable area is located in the delta region. So if we have, for example, a conservative scenario of 1 meter of sea level rise, a lot of the available arable area is lost, and it also means that a lot of salty water is flowing into the sweet water resources that are used for irrigation, thus affecting an even larger area. This could affect up to 6% of the GDP, displace around 7 million people, and would impact 10% of Egypt's population. So this would really be immense impact, and the situation would be even worse when we look at higher levels. This is a chart which is taken from the mentioned study. We can see here the scenario of 1 to 3 meters of sea level rise and the percent of impact to the GDP. Here it shows that 1 meter of sea level rise would impact 6% of the GDP. 2 meters would already impact 9% of the GDP, which means losing 90% of GDP of the country. And in the worst case scenario, 5 meters of sea level rise would mean no less than 60% of loss of GDP, which would be devastating for the. Here we can also see it in terms of area that would be lost. The dark blue part refers to like 0 to 1 meter of sea level rise, and you can see very clearly how much area would already be lost. And I said before, it's not only about the area that is lost and which is inundated under the water, but it's also about the water resources that are affected by the inflowing salty water. To summarize it, the 3 threats facing agriculture in Egypt, climate change, food security, and poverty, are associated with issues of water scarcity, land scarcity, the nutrient availability, raising sea levels, agriculture as an emitter of greenhouse gases, which was not addressed that much here, but you should look at our third part of our introduction to agriculture, and there you can see like how agriculture is affecting greenhouse gas emissions and what that means in terms of climate change. Poverty and health are also like fields that are put at risk by agricultural activities. And so the question remains, what is next? How are we going to continue? We saw that the troubles, the dangers are a lot. So Egypt is at the crossroads in the agricultural sector, and a paradigm shift is needed. How such a solution could look like, we're going to see in the third part of the introduction to agriculture. Thanks for watching.